Integrate the following. Integral of sec squared x dx divided by 1 minus tan x. Now, when we look at this integral, look at this. When we differentiate 1, it is 0. And when we differentiate tan x, it is sec squared x. But because there is a minus here, it means that we need to factorize minus out, so that this integral will be like this. So that if we let's multiply both the numerator and the denominator by minus 1 over 1, so that this becomes sec squared x dx divided by 1 minus tan x. So now let me push this one of the minus in, so this will become minus integral of minus sec squared x dx divided by 1 minus tan x. So what is the differentiation? D dx of 1 minus tan x. If you differentiate 1, it is 0. And if you differentiate minus tan x, it becomes minus sec squared x. So it is equal to minus sec squared x. So if we differentiate the denominator, we'll get the numerator. And therefore, the answer becomes minus the natural log of the absolute value of 1 minus tan x plus c. Now, for this part, we are supposed to integrate cot x. But we know that cot x is the same as cos x divided by sine x dx. When we differentiate sine x, we will get cos x. So therefore, this integral will become the natural log of the absolute value of sine x plus c, the constant of integration. Now let's come to this one. Integral of sine x divided by sine x plus cos x dx. So you see that when we differentiate sine x, you get, so let's do the test here. Let's differentiate d dx of sine x plus cos x. If you differentiate sine x, you get cos x. And if you differentiate cos x, you get minus sine x. But when we look at the numerator, we only have sine x. So we must be able to modify the numerator to look like cos x minus sine x, so that we can use the natural log. But when we look at the numerator, it does not look like cos x minus sine x. So therefore, we must be able to modify the numerator to look like cos x minus sine x. So what we will do is that let's multiply both the numerator and the denominator by 2. So that this will become 2 divided by 2 integral of sine x divided by sine x plus cos x dx. Then now this will become 1 over 2 integral of 2 sine x divided by sine x plus cos x dx. So the numerator now has sine x plus sine x. So this is equal to half of integral of sine x plus sine x divided by sine x. Sorry, there's a sine x here, plus cos x dx. So we are looking for cos x minus sine x. So what we will do is that let us add and subtract cos x to the numerator, so that it will become half of integral of sine x plus sine x, then plus cos x minus cos x, plus cos x minus cos x is 0. So in other words, we've done nothing. Dx divided by sine x plus cos x. So using this, we can break this integral into 2 by saying this is equal to half of integral of. Now let's write sine x, then plus this cos, so plus cos x divided by sine x plus cos x dx. So this is one part. Then plus integral of, we are left with 1 sine x here, so 1 sine x here. Then what is left here is minus cos x dx divided by sine x plus cos x. So you see that from here, this one and this one can cancel out. So we'll be left with minus half. Sorry, there is a half here. So half, there's also a half here. So half integral of dx. Then with this, we are looking for cos x minus sine x, but we have sine x minus cos x. So we need to pull out minus 1. So minus half integral of, when we pull out minus 1, then sine x becomes minus sine x, then cos x becomes plus cos x, then divided by sine x plus cos x dx. So you see that when we differentiate sine x, we will get cos x. And when we differentiate cos x, we will get minus sine x. So we can now use the natural log. So this then becomes, if we integrate half dx, we are going to get half x minus half the natural log of the absolute value of sine x plus cos x, then plus the constant of integration c. So we are supposed to integrate integral of sine x over cos x exponent 3 dx. So let's let a to be equal to cos x. So the a is equal to minus sine x dx, so that dx will be equal to minus dA over sine x. So this integral becomes integral of sine x divided by, now cos x exponent 3 becomes a exponent 3, then times dx, but dx is now minus dA over sine x. So this sine x and sine x will cancel out. So this becomes minus integral of 1 over a cubed dA. And this can also be written as minus integral of a exponent minus 3 dA. So if you integrate this, you are going to get half of a exponent minus 2 plus c. So our answer is half a exponent minus 2 plus c. So this can also be written as 1 over 2a squared plus c. But a is cos x, and therefore this is equal to half of cos squared x plus c. But 1 over cos x is sec squared x, so this will become half sec squared x plus c. So we are supposed to evaluate integral of cos x exponent 3 dx divided by 1 minus sine x. So we can rewrite this integral as integral of, I'm pulling out one of the cos x, so we'll be left with cos squared x dx, then divided by 1 minus sine x. But we know that cos squared x is equal to 1 minus sine squared x from trig identity. So the integral becomes integral of cos x, then cos squared x will become 1 minus sine squared x dx divided by 1 minus sine x. So we can then use this to break the integral into 2. But first of all, let's expand the bracket. It becomes cos x minus cos x sine squared x dx divided by 1 minus sine x, so that this will become integral of cos x divided by 1 minus sine x, then dx minus integral of cos x sine squared x dx divided by 1 minus sine x. So what we'll do is that we then need to evaluate both integrals independently. So let's first start with this one. What is integral of cos x divided by 1 minus sine x dx? So you see that when we differentiate 1 minus sine x, if you differentiate 1 is 0. If you differentiate minus sine x, you get minus cos x. So we need to make the numerator to look like the denominator so that we can use the natural log. So what I'll do is I'll factorize minus 1 out. Integral of minus cos x divided by 1 minus sine x dx. We have done nothing because minus 1 times minus 1 is still 1. So we've done nothing. Therefore, we can then say that this is equal to minus natural log of the absolute value of 1 minus sine x. Now, let's evaluate this one. So this is integral of cos x sine squared x dx divided by 1 minus sine x. So let's let a to be equal to 1 minus sine x. So this implies that sine x is equal to 1 minus a, and therefore sine squared x is equal to 1 minus a squared, which is equal to, so let me do it down here, which is equal to 1 minus 2a plus a squared. So therefore, this integral, now let's find dA. dA is equal to, if you differentiate 1, is 0. If you differentiate minus sine x, is minus cos x dx. So this implies that dx is equal to minus dA over cos x. So the integral becomes integral of cos x. Then sine squared x. Sine squared x is 1 minus 2a plus a. Then dx is minus, this is dx, minus dA over cos x. Then divided by 1 minus sine x, all of that we said this should be a. So that this cos x and this cos x will cancel out. So at the end of the day, there's a minus here. So let me pull out that minus. So minus integral of, then we are left with 1 divided by 1 minus 2a, then plus, here's a squared because there's a square there, plus a squared, then dA divided by a. So this will become minus integral of 1 over a dA, then plus 2 integral of dA, because this a and this a will cancel out, then plus, minus integral of, because there's a minus here, a dA. So if you integrate this, we get minus natural log of a, then plus 2a, then minus half a squared plus c. However, we said that a is equal to minus 1 minus sine x. So this will become minus natural log of 1 minus sine x, then plus 2 1 minus sine x, 2 times 1 minus sine x, then minus half of 1 minus sine x squared. However, from this side of the integral, we got minus natural log of 1 minus sine x. So if we are supposed to put it here, we are going to get this part would give us minus natural log of 1 minus sine x, then minus, so there's a minus here, times minus this, all of this, natural log of 1 minus sine x, then plus 2 1 minus sine x, then minus half of 1 minus sine x all squared plus c. So there's minus will become plus, and then there's a minus here, so this aspect goes to 0. So we are going to be left with minus 2 times 1 minus sine x. And then now this minus will cancel this minus here. So it becomes plus half of 1 minus sine x all squared. So if we expand this, here is minus 2, then plus 2 sine x. And then this one will become plus half of half, then minus half. Sorry, if you expand 1 minus sine x, here is 1 squared is 1. So 1 times half is half. Then we will be left with minus 2 sine x over this 2. And then plus half of sine squared x. So if you continue from here, this is minus 2. Then minus 2 plus half will become minus 3 over 2. And then this is 2 sine x. And 2 sine x minus 2 over 2 sine x is minus sine x. So 2 sine x minus sine x will become plus sine x. Then this is plus half sine squared x. So if we rewrite the answer plus c. So in rewriting the answer, you find out that integral of cos x exponent 3 dx divided by 1 minus sine x is equal to, I'm writing the answer down here, half sine squared x, then plus sine x, then minus 3 over 2. So minus 3 over 2 plus. So we are supposed to evaluate integral of sine x exponent 3 cos squared x dx. So let's pull out one of the sine x. So we left with sine x into bracket sine squared x, then cos squared x dx. So now we know that sine squared x is equal to 1 minus cos squared x. So the integral becomes sine x, then into bracket 1 minus cos squared x, then cos squared x for this one, then dx. So that if we expand this, this will become integral of sine x. Let me put this into bracket. Then minus sine x cos squared x, then times cos squared x dx. So we can then break this integral into 2 by saying integral of sine x cos squared x dx and minus integral of sine x then cos x exponent 4 dx, so that we can evaluate this integral simultaneously. So let's first start with this one. So what is the integral of sine x cos squared x dx? So let's let a to be equal to cos x. So dA is equal to minus sine x dx. So this implies that dx is equal to minus dA over sine x. So this integral becomes integral of sine x, then cos squared x becomes a squared, then dx is now minus dA over sine x. So that this sine x and sine x will cancel and it becomes minus integral of a squared dA. Then that will give us minus 1 over 3 a exponent 3. But we know that a is cos x, so it becomes minus 1 over 3 cos x exponent 3. Then now let's do the same thing for this one, which is integral of sine x cos x exponent 4 dx. So you see that this one was cos squared x, then we got minus 1 over 3 cos cubed x. So because this one is cos x exponent 4, Then without going through all these steps, I can write this as you add 1 to the power. So minus 1 over 5 cos x exponent 5. So that the integral of this becomes this part, which is minus 1 over 3 cos x exponent 3, then minus 1 over 5 cos x exponent 5. Sine x exponent 4 cos x exponent 4 dx. So we can rewrite this integral as integral of sine x, then cos x, all exponent 4 dx. But we know that sine 2a is equal to 2 sine a cos a. And therefore, sine x cos x is equal to half of sine 2x. So all of this becomes integral of half of 2x, then exponent 4. So this will become 1 over 2 exponent 4 is 1 over 16. Integral of, sorry, this is 2x. Sine 2x exponent 4 dx. So there is a dx here. We can rewrite this as 1 over 16 integral of sine squared 2x, then all squared dx. I will know that sine squared a is equal to 1 minus half of 1 minus cos 2a. Integral of, so there is 1 over 16 here. Then into bracket, sine squared 2x is half of, so let me put half here into bracket, 1 minus cos 2 times a, and then a is 2x, so 2 times 2x, then all of this squared dx. So this is equal to 1 over 16 integral of 1 over 4 and times. Now this will become 1 minus cos 4x all squared dx. So 1 over 16 times 1 over 4 will give us 1 over 64. Then times integral of, now if we expand this, 1 squared is 1, then minus 2 cos 4x, and then plus cos squared 4x, then dx. So we can then break this integral into smaller integral so that we have 1 over 64 integral of, 64. So let me rewrite this, 1 over 64 integral of dx, then minus, now 2 divided by 64 is 32, so 1 minus, so minus 1 over 32 integral of cos 4x, and then plus 1 over 64, 1 over 64 integral of cos squared 4x dx. So there's dx at all of these places. Now let's do this integral. What is integral of cos squared 4x? So let me write this well, dx. We know that cos squared a is equal to half of 1 plus cos 2a. So this becomes integral of half of 1 plus cos 2a. Here's 4x, a is 4x, so 2 times 4x becomes 8x, and dx, which is equal to half of integral of 1 plus cos 8x dx. And if you integrate this, you get half x, then plus half of 1 over 8, then sine 8x. So this will give us half x, then plus 1 over 16 sine 8x. So we are done with this part. So all of this will be times 1 over 64. So all of the integral becomes, if you integrate dx, you get 1 over 64x. That is from here. And then if you integrate cos 4x, you get to minus 1 over 32 times 4. Then sine 4x. Then plus 164 and into bracket half x, and then plus 1 over 16 sine 8x plus c. If you expand this will give us 3 over 128x, and then minus 1 over 128 sine 4x. Then this one becomes plus 1 over 1024 sine 4x. Then sine 8x. Then plus c. So what we can do is that we can factorize 1 over 28 out. 1 over 128, sorry. So that we'll be left with 3x. Then minus sine 4x. And then plus 1 over 8 sine 8x. All of this plus c. So we are supposed to integrate cot x exponent 3, then cosec x exponent 7 dx. Now, let's pull out one cot x. So we become cot x, cot squared x, then cosec x exponent 7 dx. And then what we do is that we know that from trig identities, 1 plus cot squared x is equal to cosec squared x. So it implies that cot squared x is equal to cosec squared x minus 1. So this can become integral of cot x times cosec squared x minus 1 and cosec x exponent 7 dx. So now we can then expand this to become integral of here's cot x. So this becomes integral of cot x cosec squared x, then minus cot x, then times cosec x exponent 7 dx. So we can break this integral into 2 to become integral of cot x, then cosec squared x times cosec x exponent 7 becomes integral of cot x cosec x exponent 9, then minus integral of cot x, then cosec x exponent 7 dx. So there's also a dx here. So what we'll do is that we'll take all of these individual integrals and then evaluate them. So what is the integral of cot x cosec x exponent 9 dx? So let's let a to be equal to cosec x. dA is equal to cot x. There's a minus here. If you differentiate cosec x, you get minus cot x cosec x dx. So this implies that dx is equal to minus dA divided by cot x cosec x. So this integral becomes integral of cot x. Then now what I'll do is that I'm going to pull out 1 cosec x so that we get cosec x because of this denominator. Then the cosec is now left with 8. However, cosec x is a, so it becomes a exponent 8. Then times dx, but dx is minus dA divided by cot x cosec x. So cot x cosec x will cancel. So we are left with minus integral of a exponent 8 dA, which is equal to minus 1 over 9 a exponent 9. And that is minus 1 over 9 cosec x exponent 9. Now, so we are done with this aspect. So we need to do this one. Now, you see that if you look at it, this is cot x cosec x exponent 9, cot x cosec x exponent 7. They are all odd powers. So this one, it's just the same thing. Minus 1 over 9, and then cosec x exponent 9. So it implies that integral of cot x cosec x exponent 7 is also equal to minus 1 over 7 cosec x exponent 7. I don't want to bore you with the same proof. So if you go through all of these steps, you will get this answer. And therefore, this is equal to minus 1 over 9 cosec x exponent 9 minus 1 over 7 cosec x exponent 7 plus c. So this is the final answer.